Welcome to WOW TV. My name is Angel and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today we're going to talk about density. Are you ready to get started? Density is a science word that talks about how tightly packed the molecules are in an object or a substance. Imagine yourself in an elevator. As it travels from floor to floor, it picks up and drops off passengers. The volume is the size of the elevator. It's the amount of three-dimensional space occupied by an object. If 2 passengers are added, the density will change. If those 2 passengers were molecules, the elevator's density is low. As more mass or people are added to the volume of the elevator, it becomes more tightly packed. The crowded elevator is more dense than when there were just 2 people. An object with tightly packed molecules is more dense than one where the molecules are loosely packed. Here, I have 2 1-liter bottles. The one we packed with cotton balls is less dense than the one we packed with beads. Teachers, if you'd like to have a visual for the elevator example, use masking tape and create a large square on the floor representing the elevator. Have 2 students stand in the square and show how much room there is. Change the density by continuously adding students until it is very crowded. If you want to do this activity, go ahead and pause, and we can continue in a bit. Let me ask you a common trick question. Which is heavier, 1 kilogram of gold or 1 kilogram of feathers? You can't be tricked. Neither one is heavier. They weigh the same. 1 kilogram equals 1 kilogram, whether it's gold or feathers. They both weigh 1 kilogram. Here's another question. If you had 2 equal boxes and you filled one with gold and one with feathers, which box would be heavier? The box of gold would be heavier because gold is denser than feathers. The same volume of feathers would be lighter. This is a polydensity bottle. Let me show you what happens. Now, we'll come back to that later and talk about how it works. In the meantime, as we talk more about density, maybe you'll be able to explain it without me. Remember, density can be thought of as the amount of something packed into a specific volume. For example, think about what it would look like if you packed a suitcase or a toy box in a real messy fashion versus folding clothes carefully. The carefully folded suitcase will hold more clothes, so in the end, it will be heavier. If we think about this scientifically, the item with more mass in the same volume, our carefully folded suitcase, is heavier and has more items tightly packed together. Let's do an activity. Teachers, let me show you what materials will be needed. Each group will need 1 worksheet, a tray to work on, a plastic cup, and 3 different spheres. In a moment, please fill each group's cup halfway with water. They should carefully and slowly place all 3 spheres in and observe what happens. Perhaps you should make predictions first. One is made of wood, one is cork, and one is steel. Will any of them float or sink? Go ahead and pause while you complete this activity. When everyone is finished, you can collect most of the materials, but leave each group the tray and the cup of water. I'll see you back here when you're ready. How did that go? Did you see that the one made of wood was more submerged? This shows a difference in density. When an object has less density than the liquid it is in, it floats. That means it's buoyant. Let's get ready for your next activity. In a moment, each group will need one of the handouts, a digital scale, a calculator, rulers, and an aluminum bar and cube. When you get them, you'll see 3 different colors on the bar and the cube. Use those colors to measure the length, the width, and the height. Your goal is to find the density of these objects. How do you do that? Well, density equals mass divided by volume. So that means we need to find the mass and the volume. You can use the digital scales to find the mass. And then to find volume, multiply length times width times height. Then you can find the density, the mass divided by the volume. Teachers, please pause as you have the students calculate the density and compare the density of both of those objects. You can then collect the bars and the cubes, and I'll meet you back here for the next set of directions. Did you figure out the mass, the volume, and the density of these items? Was the density in the bar and the cube the same? Let's set up for your next activity. Each group will need a set of the density cubes. If you measured and multiplied length times width times height, you'd see they all have the same volume, but they do have different densities. Let's talk about something new. If the volume is the same, do you know what will determine the density? The mass will tell us density. And how do we figure out which is the most dense object? Well, we have to figure out which is heaviest. Your task is to put these cubes in order of the most dense to the least dense. Now, before you use the scales, see if you can figure it out by feel first. Then, once your team agrees, check by using the scale to calculate the density. Teachers will pause again for them to complete this. When everyone is finished, please collect the density cubes. There is an additional challenge activity involving the constant volume and constant density of cylinders. If you choose to have your students do this activity, pass out the cylinders once the cubes are collected. You can find information for activity number 4 in the binder. I'd like to show you these layered liquids. Liquids also have density. Liquids that have more mass per unit, or in other words, a high density, will sink below other liquids. Due to the properties of liquids, they can be mixed, but will always separate back out and layer in their order of density. Watch. Keep an eye on that. Let's go back to the polydensity bottle we talked about earlier. Do you see that the items are separating? When liquids of different densities are mixed, they will always separate out again. How does this happen? In the bottle, we have water, salt, and isopropanol, which we also call rubbing alcohol. When the salt particles bind with the water molecules, they force the alcohol molecules out of the way. This causes 2 layers to form. The rubbing alcohol on top and the water and salt, which are more dense, go to the bottom. When we shake the bottle, the layers mix. The white beads have a lesser density than the liquid mixture, so they float on top. The blue beads have a greater density than the mixture, so they sink to the bottom. As the salt water layer separates from the alcohol, the blue beads rise and the white beads sink until they meet in the middle. I hope after today's activities you understand more about density. You all did a great job today. Thanks for joining me. Teachers, thanks so much for using this WOW lesson, and please check out more at our website at wpafbstem.com.